The current global strategy for handling heavy industrial carbon emissions is straightforward. Capture the gas at the source and pump it deep into the earth. This method, traditional carbon capture and storage, relies on keeping carbon dioxide in a pressurized gaseous state. For this to work, the chosen rock formations must maintain a perfect geological seal for centuries to prevent the gas from migrating back to the surface. Because we are dealing with a gas, any natural subterranean fault line or structural shift creates a pathway for that CO₂ to escape. If the pressurized gas finds a way out, the storage is no longer permanent. This approach treats carbon dioxide as a hazardous waste product, a liability that we simply move from the atmosphere to a hole in the ground. By focusing solely on storage, we are managing the symptoms of emissions rather than changing the nature of the carbon itself. Natural geology offers a different path through a process called mineralization. Mineralization uses a chemical reaction to bind carbon dioxide into a solid form. This reaction requires specific reactive elements: calcium, magnesium, and silicates. When CO₂ molecules meet these minerals, they begin to form new chemical bonds. As these bonds lock together, the carbon dioxide is transformed into a stable carbonate material. The gas has been replaced by a solid stone. It is no longer a volatile vapor, it is a physical mineral. Because the carbon is now a solid, it can no longer leak through rock fissures or escape into the atmosphere. The need for constant, long-term geological monitoring disappears. While this happens naturally over thousands of years, biogenic Orja is engineering this process to work at an industrial pace. Their technology intercepts emissions directly at the factory smokestack, capturing the CO₂ before it can disperse. Inside their reactors, they provide the optimal conditions for mineralization to occur in hours rather than millennia. This shifts the focus from passive storage to an active industrial process, allowing heavy emitters to neutralize their carbon footprint immediately on site. Instead of simply mitigating an environmental cost, the facility becomes a site for carbon transformation. This chemical change creates a material that stays stable for thousands of years, providing a level of carbon security that gas storage cannot match. Because the resulting carbonates are chemically inert and physically durable, they do not require specialized containment or maintenance. This process changes the economic math for heavy industry by converting a gaseous liability into a physical asset. Industrial CO₂ emissions flow into the reactor, emerging as standardized construction aggregate. The old model required companies to pay to hide waste underground. In this new model, that carbon is processed into material sold directly into the construction supply chain. Mineralization turns carbon management into a manufacturing process. The result is a future where our cities are quite literally built out of the emissions of our past.